Fantastic. Okay, well, good afternoon. Thanks for coming to the talk. Welcome to DevOps World. Today we're going to talk about containers on AWS and essentially a state of the union with respect to containers. We're going to talk about ECS and EKS and Fargate and ECR. And what I'm not going to do today is give you a super deep dive. What I want to do is give you a very broad orientation. And as part of this, something that you don't hear in a lot of talks, I'm going to take time at the end to give you a bit of opinionated conversation. I'm going to make some recommendations for people here in the crowd and hopefully put you on a nice accelerated path towards success with containers on AWS. So I'm Tony Pujols. I'm a fairly recent developer advocate at AWS. I'm a Docker captain, certified Docker associate, and last year I was director of cloud R&D at Accelerator. So I was involved in those kinds of decisions that we all face when we're trying to figure out how to be effective, how to embrace cloud technology, how to keep up with the trends, best practices, and be cost effective. So a little bit of background. This is probably going to be old news for most of the people in this audience, but just to make sure we're all on a level playing field, I'll give a little bit of background before we get caught up. Containers. So what are containers? Really, just think about containers as a universal binary at this point in time. Okay, containers are how you're going to package up and distribute your applications where you're in control of how that application, how that service, whatever it is you're deploying, is going to run. It's going to run in a runtime environment that you dictate, that you declare using this nice declarative format thanks to Docker that makes it really easy to define this runtime environment and make sure that what you ran on your laptop or what you ran in a staging environment or in your CI environment is going to run that same way in your production environment. So traditionally, if you wanted to be in control of that runtime environment, and I mean traditionally as in ever since virtual machine technology, because I'm not even going to talk about the old days where you sat there and SSH'd the machines and set things up manually. But since virtual machine technology came along, we were able to create these environments that we could push out into servers that would run the way we wanted it to run. And there was nothing wrong with that model. That model actually worked really well. And it's obviously the basis for Amazon itself, for the Elastic Compute Cloud and the way we were able to provision servers on demand for our customers. But when you contrast a virtual machine with container technology, what you realize is a virtual machine is a fairly heavyweight solution to the problem. We want isolation of our processes. We want these processes to be isolated from being impacted by any other processes that are running on the system. And certainly and you get that with virtual machine technology, but also in this day and age, we want our processes to start up as quickly as possible. We don't necessarily want to have to start up virtual machines just because we want to scale. And we don't want to have to ship around a virtual machine, which is effectively a computer, and have to maintain these the way we maintain computers. So installing the guest operating system and ensuring that it's configured the way you want it, come up with your golden master, and then maybe running scripts to update stuff inside of that environment using Chef or Vagrant or tools like that. What we get with container technology, which is perfect for this modern world, this world where we have this explosion in devices that are connected to the internet. It's not just websites, it's all of your connected devices, your smartphones and your tablets and your cars and your refrigerators and everything else. And this demand, the marketplace demands services, and services that are updated frequently, and services that can scale to demand, and yet you have to be cost effective in how you manage those. You don't want to over provision. And containers allow us to make this modern world, these services that have to start up quickly and scale out and then scale back, a process startup time on Linux. That's what we get with container technology. So these containers are going to run on a system that's got a Linux kernel The distribution won't matter. What you installed on that distribution, you won't be worried about patches or anything like that. You're going to ship just what you need to ship as far as the runtime resource requirements for your specific process inside of a container. And that's what we get. I kind of jumped ahead because that's why containers are so popular. They're portable, they're lightweight, standard, easy to deploy, all that good stuff. Okay, and as I already alluded to, they make this decomposition of monolithic style applications that we used to ship in VMs. They make this whole movement towards this partitioning, this decomposition of applications into services, so that an application is just a specific set of services that you need to provide a user experience on a specific device. They make that microservice type of architecture pragmatic. So first, our customers, and obviously Amazon with EC2, we owe a lot to our customers from the startup community. This ability to be able to create and provision your servers on demand. EC2, this is the genesis of being able to take advantage of being in the cloud. And when you started moving towards Docker, the first stage was to run a Docker daemon on an EC2 instance so that you could run your containers on that EC2 instance. And while tenable, perhaps at a small scale, it's not really tenable at a large scale. Okay, so we had customers say, how can we make this easier? And this is a common problem for everybody trying to take advantage of the benefits of Docker and deploying Docker into their production types of environments. So that brings us to Amazon Elastic Container Service, ECS. So with ECS, the problem that we're solving is that, yes, we're taking advantage of container technology to wrap the processes that we want to be able to deploy, these are the applications that we want to deploy so that these processes can start up and run exactly as we expected, as we had configured and as we had tested in other environments. And as I said, one of the value propositions of Docker is to be able to take advantage of scalability. But if you're taking advantage of scalability, at some point you need more and more instances. You need more nodes. In managing clusters, managing things in a cluster, distributed computing, this is hard. It's painful. It's a pain point. It's what we call, and extending on this concept that began with EC2 in the first place, but undifferentiated heavy lifting. The work that you do to manage a cluster is work that you have to do, but it doesn't really help you. It doesn't help you solve the business problem that you wanted to solve. It's just helping you solve a performance problem. So with ECS, we provide cluster management as a hosted service and cluster management at scale. The idea that you get to take advantage of the performance and the reliability and the scale, the breadth and the depth of Amazon services, running your containers at scale. And that's what we mean by a managed service. It means that we're going to manage that for you. We're going to do the heavy lifting. We're going to take care of scheduling those containerized applications to the appropriate compute resources, placing them on those resources, task management around health checks and things like that, and updating the control plane for running your containers inside of a cluster designed to run those containers. Now, we're gonna talk a little bit more about how this is evolving, but what you get with ECS is the ability to be able to run containers in an EC2 cluster with management around Docker and ensuring that your ability to run these containers isn't going to be hampered by your ability to manage the cluster itself. You're not going to be SSHing into EC2 instances and installing Docker and things like that. So it's a managed platform, high performance, highly scalable, provides you with cluster management, container orchestration, and deep integration into the rest of the AWS platform. And what we see with our customers is up to a 70% reduction in their compute footprint once they start taking advantage of ECS. And that's not to speak to the actual, the reduction in other overhead, the personnel effort in maintaining these clusters. You get a very big benefit if you're going to containerize. And again, this is where I'm going to get to the opinionated piece at the end. You should be containerized if you weren't already. You should be containerizing. You're going to get the ability to run. Today, right now, we have tens of thousands of customers running hundreds of millions of containers per week on our ECS infrastructure. It's a substrate for other Amazon, AWS services like Batch and Fargate, of course. So we rely on it ourselves. So in 2018, ECS has been around actually since 2015, and some of the recent improvements include faster launch times, and it's a big list, so I'm just going to keep clicking here. But lots of nice features, updates for Docker. We added daemon scheduling, the ability to have shared memory support, shared memory file system support, Docker container health checks, Compose v3 file support, a bunch of stuff. So if you're working with Docker, you've already been working with Docker, then these are going to be meaningful updates for you. So once you go down this road and you're containerizing, the fundamental unit of deployment is the image itself. The binary bits that you ship are an image, and you have to store those somewhere. Docker Hub is a public registry used by the open source community, and a lot of companies for storing their images, so that these images can then be pulled down to the individual machines that are going to run Docker containers. With ECR, we provide a fully managed and integrated registry, integrated with ECS, and one that makes sense for you as an AWS customer. It's going to be integrated with IAM, so it's going to use the security model that you're already familiar with as a customer. Fully managed, highly available registry service to ensure that your applications can get those images and start up as quickly as possible when you're spinning up containers. Simplified workflow, what that means is that, not sure if this is scaling the way I intended. What this means is that you can actually set it up so that you're using Docker and the Docker CLI to push images up to the registry, and it's going to provide this mapping. This command here is showing how you can go ahead and get the login support that ensures that when you're using the Docker CLI, your images will actually get pushed up to the AWS registry. All right, so now I'll skip ahead a little bit. We talked about ECS, and ECS is our container orchestration solution, is our traditional container orchestration solution since 2015 for EC2. Now Kubernetes is this very popular open source container orchestration platform that has come onto the scene and become very popular with the developer community. It's a huge community-driven project. There is a lot of work going into Kubernetes. There's a ton of special interest groups, or SIGs. There's the Cloud Native Compute Foundation that's providing a lot of guidance and certification for Kubernetes and education around Kubernetes. This has become a very popular way to manage, an open way to manage your container orchestration. And at Amazon, we listen to our customers. We've had a lot of customers tell us that they'd like to be able to use Kubernetes on AWS. And so the last survey that the CNCF did showed that over half of all the Kubernetes workloads in the world today are being run on AWS anyway. So if you are going to run Kubernetes, just like in the old days with Docker pre-ECS, you'd have to provision your own cluster, and then you'd have to go through some kind of process to install and set up Kubernetes and manage the Kubernetes control plane, as well as all of your worker nodes to run your application under Kubernetes as the orchestration engine. We had customers ask us, well, make it easier and provide us that same kind of integration with AWS that we get with ECS, provide us the ability to take advantage of the breadth and the performance and the scale of the AWS platform, security, and all that kind of stuff, just like we do with ECS. And yet, allow us to work the Kubernetes way. Let us use the same Kubernetes tooling that we're used to, the kube control and other tools that are part of the Kubernetes platform. Don't make us change the way we work with Kubernetes. We just want it integrated. All right, so that brings us to EKS, our Amazon Elastic Container Service for Kubernetes. So I mentioned CNCF before. CNCF certifies Kubernetes applications and environments and tools. EKS is Kubernetes certified, so that means that there was a conformance suite that had to be passed. So if you deploy your Kubernetes applications to EKS, then you can expect it to run the same way you would expect it to run in any other environment. And for many developers, many customers, that is the value proposition of Kubernetes, is this idea that they can run their orchestrated applications in different environments, including their on-prem or hybrid cloud facilities. So that's what we did. And that gives us the ability to provide our customers with this enterprise-grade, production-grade Kubernetes platform. So you get a Kubernetes managed experience. You get seamless integration with AWS services, and what we do at Amazon is we also provide the integration is done in an open way. We do that integration working with the open source community. We have so all the integrations, whether it's related to security, whether it's related to our networking plugins, it's done as open source projects, and there's work that we also do to contribute back to the upstream community. So this is all part of our open source commitment, all part of being a member of the Kubernetes community. So what does this actually mean when it comes to Kubernetes? Because Kubernetes is interesting. What we're doing is that we are, and I'll kind of click through these little animations here. What we're doing with Kubernetes is that by providing a managed experience, what this really means is that we're going to run the control plane for Kubernetes, and we're going to run it for you. We're going to run it as a highly available cluster, so it's going to start up in multiple availability zones, and we are going to take care of running the Kubernetes API server, the stuff that needs to make Kubernetes do the work of managing your cluster. And what you're going to do is you're going to take responsibility for your worker nodes. So you're going to create a VPC, and then we're going to connect into that VPC and manage allow Kubernetes to manage the orchestration of services inside of the cluster running on your worker nodes. So we'll take care of the control plane, you'll take care of the worker nodes, and that's how it's going to work. So now that you're working with Kubernetes, you're still managing nodes. You're still dealing with the nodes in a cluster. You're still managing some infrastructure. And again, the question is how do we make that easier? And this is true whether it's you're using ECS for your orchestrator, you're using Kubernetes for your orchestrator, you're still dealing with the infrastructure around instances. And so that brings me to AWS Fargate. And Fargate is our solution for, we call it a compute engine. It's our compute engine so that you can focus on running containers without having to focus on managing servers. What this means is, many of you are probably familiar with or have heard of serverless. This is sort of like serverless. This isn't the idea of function as a service. We're not taking your code and we're going to run it for you. Event-driven runs inside of a certain time frame and it gets work done. But what we're going to do is, this is a container as a service. We're going to you're going to define the tasks, which are going to be based on the containers that you deploy, the services that you want to run, and we're going to run those tasks on our infrastructure. We're going to manage that infrastructure for you. And we're going to manage that, though, at AWS scale. You're not going to have to provision the cluster, and you're not going to have to try and figure out how to decide which instances you're going to need and what's the appropriate size and how you pack those instances to fully use the resources that you provision, that you're paying for, to run all the tasks that you need to run inside of that cluster. You're going to specify maybe how big your tasks are, how much memory, you have control over how much memory you'd like for each individual task, or how much compute resource you'd like to assign to it in terms of virtual CPU units. But we're going to provision the infrastructure for you. You're going to handle things at the container level. And we're going to handle the fact that it's going to scale seamlessly as it needs to. So again, this is just repeating what I said. No worrying about scaling, underlying infrastructure, resources, capacity, setup. You're going to give it a task definition, and what this, or potentially a pod soon, which means that whether you're coming through ECS or through EKS, you'll be able to define what those tasks are going to be like, and we're going to run them. Focus on your workload. That's what this is about. What we're saying is that you want to think about the tasks that you need to run, the jobs, container, services, and that's it, full stop. So how does this work? Well, today, you actually are going to, you can only do this with ECS right now, but when you are working with ECS, you'll have a choice when you launch to either launch into EC2, which is the traditional type of instances, or you can use Fargate as your launch type. And if you use Fargate as your launch type, that's when we take over and we handle the provisioning of your infrastructure and run your containers for you. I mentioned that you'll have some control over the size, the performance requirements that you need for your tasks. So you can see that we've got these vCPU units and we've got memory units. You can, again, this is more specific to the workload. You can provide this guidance around the workload, but you don't have to sit here and do the calculation around the kinds of instances that you actually need and what is the appropriate sizing to best leverage and pack those with your running containers. Now, as far as the pricing model goes for Fargate, you're going to pay for what you provision, which is going to be the task that you define. You're going to be billed at the CPU and memory level. You're going to be billed for the first minute. It starts at the first minute, and then it's per second pricing. Okay, so one thing that people have commented about is that Fargate, on paper, looks a little bit more expensive. That's going to be a true statement. If you look at how much it's going to cost to run your tasks on an EC2 instance that you provision yourself, you may see math that makes it appear that it may not be in your favor to take advantage of Fargate. So this is going to be where you have to decide on the economics that makes sense to you. You'll have to decide how much effort you're spending on managing those resources yourself versus how much you're benefiting and gaining from having the resources managed for you as effectively and as efficiently as possible. There is a cost associated with that, and this is a decision that you'll have to make. I'm going to emphasize a couple things. With Fargate, you are thinking of the container itself as your fundamental compute primitive. And what that means is that you're not thinking about your instance as your fundamental compute primitive. You're not focused on machines. You're focused on deploying the services that you need for your application. When you create a task for Fargate, you're going to set up the IAM roles that you need. You're going to define the scaling requirements that you have. You'll set up any load balancer requirements that you have for public ingress to the application, and you'll set up AWS VPC networking mode so for your tasks to be able to communicate with each other. But that's it. you're not creating and managing an EC2 cluster. So I'm going to summarize here real quick. When it comes to Fargate, what you're seeing is the beginning of a convergence, I think, that's happening across the industry in terms of the ability to run workloads without having to manage infrastructure, and everything from serverless to service mesh and all of these concepts that are around making it easier for your application to run the way you expect it, with you focusing on the services of that application or the functionality of that application without actually having to focus on the hardware for that application and spending time administering that, maintaining it, managing it, calculations that you have to do around it. In my opinion, Fargate is a fantastic model, and I'll save some of my a few more points around that towards the end. I'm going to wrap up right here on the AWS container landscape, though. We've covered ECS, EKS, Fargate, and I also talked about ECR. ECS is our highly scalable, high-performance container management platform. So again, if you're containerizing today and you want to run those containers in an environment that provides you with container orchestration, which means the ability to schedule these containers onto nodes that are ready to run Docker services, as opposed to your classic services that you would have to install on them, you're going to go with ECS. And if you want to take advantage of an open source container orchestration platform, then you might be attracted to EKS, which is the AWS managed Kubernetes service that we provide. And for both of these, you're going to have the advantage of you're going to have AWS deep integration into all the rest of the services that you expect from the platform. You're going to have the security model that you're familiar with, the networking models that you're familiar with, and the performance and scale that you expect from AWS. And if you want to move away from focusing on infrastructure and just focus on the tasks that you need to run, these services that are a part of your application that you want to deploy, then I encourage you to take a look at Fargate. Fargate's going to let you build your applications, get them up and running quickly. You're going to be able to launch and scale quickly. You're going to be able to manage things at the container task level as opposed to the infrastructure level. And you're going to be getting resource-based pricing because you're going to be paying just for the workloads themselves. This is an article that my colleague Nathan Peck wrote, so if you're looking for help choosing an option, you might want to look at his article. And this link, this whole deck will be published, so you'll be able to get this link again later. And I want to draw your attention to this slide, which is if you are moving towards a microservice-based architecture, we have a lot of support for your microservice-based applications. Containers is just one part of that. There's a couple of ways of skinning this cat in the modern world. You can set up your own EC2 clusters and provision your own services on them. You can maybe go the other route if your application fits a model where you are event-based, your workloads spin up on demand when you need it. They do some work and then they quit. You may be attracted to serverless on Amazon, so a Lambda style model. But if you want to be in control of the environment that your services are going to run in, and you've got a number of long running tasks as well as tasks that maybe do some work and exit, and you want to ensure that these tasks run in every environment, from your development environments through your testing and staging environments into the production environment, then you're going to want to take advantage of container technology, and you're going to want to leverage ECS or EKS or Fargate. But your applications have access to a whole wealth of other services that make your applications functional. So from the compute platforms that I just discussed, you've got a number of choices for your inter-service messaging, queuing and notifications, a lot of database options, and these are all options that are meant to be able to integrate easily into your containerized applications. So whether it's Amazon DynamoDB or Aurora, which is Amazon's fastest growing service ever, and even today, serverless Aurora, which provides the ability to actually start up your databases and on demand. Again, a ton of options here. Networking, your load balancing, your DNS, your API gateway support, all here, all part of this portfolio for your microservice applications to run on Amazon. Got a number of links here for getting started. Obviously, the docs are a good place, but a few blogs here that might also be helpful. There's more, but this is just a starting point. Last screen, but I tell you what, so I'm going to leave this up for a second, but I'm going to talk now. This is the part where I wanted to be able to give my opinionated message. First of all, I want to say that if you have any questions and want to reach out to me personally, please feel free to email me. I do my best to answer all the emails. I can't always answer as quickly as I'd like, but I don't ignore emails, so I will answer. Happy to have conversations with people, and if you have questions, definitely feel free to reach out. I won't know all the answers, but I'll put you in touch with other people who do, or I'll find the answers and I'll get them to you. I'm willing to set up online office hours and answer a lot of the questions. And then if you want to ping me on, you don't have to follow me. You can send me direct messages on Pinger. I accept DMs, private messages, and you can chat. Again, I may not always be able to answer right away, but I'll do my best. Of course, if you follow, that's great. I appreciate it. But all right, so now I'm going to stop for a second. I'm going to, let's just leave this up on the first screen. I can't get to the first screen fast enough. All right, I know there's a fast way. I just don't know the fast way. Thank you. So I want to back up now. All right. We have these talks. We can go over what's available on the menu, and alternatively, we do talks where we do deep dives, and you drink from a fire hose, and we show you a whole bunch of stuff, and technically that's great. You can see a lot of that stuff online, though. We have plenty of videos that show you how to come up to speed on these different things. I'm going to answer questions here in a moment, but first of all, let me ask, how many people are already in this audience are already using ECS or EKS? Wow, a lot. Okay. So this was supposed to be an introduction, right? Well, there's quite a few in here. Okay, so one of the things that I find is that people ask, they do ask for opinions. My opinion around whether you go with ECS or EKS, this is going to be a decision that you have to make about where your comfort zone is. EKS is a wildly popular open source project. And that's great, that's fantastic. There's a lot of comfort in using something that's widely adopted by industry. There's a tremendous amount of innovation going in there into the project. It's iterating pretty quickly, and a lot of problems are being addressed by a very big community. There's something like 1,800 contributors to the project, just to the core project, and it's big, it's huge. So if you choose Kubernetes as your orchestration layer and you want to use Kubernetes on Amazon, that's great. From our perspective, we're really happy if you're using AWS and you're solving the problems that you need to solve. There is cognitive overhead, I think, to learning Kubernetes as well. It's worth it if in your mind that cognitive overhead makes it easy for you to run your orchestration solution in different environments. And if that's important to you, you should probably go that route. If you are just trying to get your applications up and running and you want a very performant orchestration solution that's deeply integrated into our infrastructure that isn't tied to the cadence of an open source project, and one that is definitely customized for the best performance and the greatest rate of advancements that we can give you, then you may want to go with ECS. Either way, you're using infrastructure. So again, from our perspective, I'm not trying to sell you on one or the other, but I'm trying to help you make a decision. I see a lot of people struggling over, do I use Kubernetes? I mean, it's the bee's knees. Everybody loves Kubernetes. Kubernetes is fantastic, but again, you're gonna probably spend a little more time trying to get your applications a little more overhead maybe in dealing with this abstraction that is meant to work across different cluster environments. It's not necessarily a bad thing, so I want to point that out. But either way, whether you go the ECS route or you go the EKS route, Fargate is going to give you the ability to focus on your tasks. Now, we're not ready yet. Fargate isn't supported as a launch type on EKS yet, but it is supported on ECS. And again, this is going to give you this ability to focus on the application and the services on that application and not on infrastructure. So again, the economics of that is up to you, but if you're focused on getting your application out the door and you're not really interested in supporting a huge DevOps and SRE kind of effort, you really should take a hard look at Fargate. I think Fargate and where Fargate is going represents the future. This convergence around serverless and everything that's about making it easier to deploy an application, and not focusing on infrastructure. This is the way to go. So I think you're going to find that to be a very attractive option for your teams. So I'm going to stop right here, and we have a few minutes left. Take any, actually, I apologize. I actually can't take any questions standing up here. I have to finish the talk, and I can take questions down there. And the reason why is I am still a new developer advocate, and we have a protocol internally at Amazon. I have to be speaker certified to be able to answer questions up on stage. So I can answer all of your questions once I go down there. My boss is at the back of the room, Justin Graham. And he walked in and caught me, so I remembered. I can't answer questions up here, but I can answer them down there. And like I said, please feel free to reach out to me, either direct message on Twitter, send me an email. Really happy to chat. And I will be down there, so anybody wants to chat after this, come see me. Thank you.